Hello. So it's another AI day, and it's really great to be here. And thank you so much for a really fantastic audience. This is the fifth time that I'm doing this. I'm getting more used to it, but every time, it comes with great excitement. The ability to be able to bring more exciting development from VinAI and be able to share all of that with you. But let me very quickly go back to the beginning, right? So just a bit more than 4 years ago, VinAI was founded. So it was a very young company. We were a very young company. Back in 2019, I was the only employee in the company, right? And today, we managed to grow a great team of research scientists and engineers, and we're also running a full-blown, really successful AI residency program in Vietnam. We have a research team doing a lot of interesting research in machine learning, computer vision, natural language understanding. We have a product team that's working on 2 areas, smart mobility and smart edge. And we also acquire core expertise in AI optimization, and that's really provide a lot of our unique differentiations in our product offering. So just to give you guys a summary of what we've managed to do over the last few years, very short period of time, and try to build up a research group. We managed to break into the top 20 of all the global companies in terms of research, AI research capabilities. And that was a report being generated by Thundermark Capital. They were looking at who's actually publishing in all these conferences, Generative, ICML, all the top 2 conferences in AI. And they come up with this list, really fantastic big names, and we managed to break into the top 20, very small company from Vietnam. So I think that's really an really outstanding achievement from the team. As we're doing this, somehow we managed to publish almost 150 publications, all in top-tier conferences in AI. And this is really a remarkable achievement from a small team in Vietnam. We're actively filing for patents. We have a few patents already awarded. And we managed to train more than 100 AI residents. And these are really provide really the future talents, really important for the development of AI in Vietnam. Now, our product in smart mobility, focusing on the really important problem of how you can actually make transportation safer and more convenient. And today, we have a range of product offering from systems that looking at the driver, figuring out whether the driver is feeling drowsy, and be able to remind the driver to wake up, right? So it's a really important component in making sure that driving is safe. We have systems that can actually work quite magically by looking at, again, the driver position of the face and the eyes, and somehow adjust the mirrors automatically for you. So it's really a magical experience for the driver, and there will be a really interesting announcement at CES in 2024, January. Really interesting new announcement, and that's all I'm allowed to say about it at this stage. Okay, so please follow us at Vegas back in January. Okay. For Smart Edge, we've actually launched our Smart AI camera system, and at the moment is serving more than 10,000 camera streams in residential area. And our system, because of our ability to optimize the AI models, we managed to bring significant cost saving for our clients when it comes to hardware investment and also operation cost. Okay. Now, of course, 2023, for the last 12 months, it was a big surprise to everyone when ChatGPT was released. right, is actually just a little more than a year ago. So that has seen really an explosion of interest, potential applications to everything that has to do with generative AI. Okay. So people now talk about a really revolution in terms of conversational interface. The way we interact with the computer has changed forever. And that just has huge ramifications. The ability to generate really precise and realistic images and photos are, of course, so important and so impressive and so useful. And that brings about a lot of impacts and changes when it comes to content creation, assistance, and so on. And the collaboration between human and AI is going to be a future of work. Right? So all of these are really profound changes that we have to deal with. And all of this happened in the last 12 months. It's really amazing, really exciting period to be alive. By the way, this slide was created with the help of ChatGPT. It actually was 95% done by ChatGPT. Right? All the images and the text contents. Right? Quite impressive. Okay, so being an AI research lab, it's actually fortunate for us that we've actually worked on generative AI before generative AI is actually popular. Okay? So we recognize that there are multiple issues and challenges remain. And some of them have to do with the quality and the capability of the system. It has to do with the issues that the system can be misused, whether it's trustworthy enough, and also, very important, right, whether the system is too costly or consumes too much energy and power to run and serve. And of course, there's an issue of making sure that the system is accessible and available to everyone. Okay, so let's talk about capability and quality. So how do we ensure that the systems continue to improve? And a lot of research at VinAI has been about exactly that. Particularly in the areas of image generation, we've worked on systems that improve the quality of image generation. We've worked on systems that be able to generate images of very, very high resolution. For example, 6,000 by 6,000. And we've also worked on a system that can actually consistently generate 3D rendering of objects. Okay, so all of these are cutting edges, and all of this research is something that we've done very recently and also actively working on it. All of this work published in top-tier conferences, CVPR, ICCV, for the last 2 years or so. Okay, what about misuse and trustworthiness? Now, the ability to generate so realistic image that might not be real, right? I mean, it comes with actually serious issues when someone tries to use it for the wrong purpose. So, take an example. If this image was somehow generated and put it on social network during the height of a close election, right? It could actually influence the outcome of the election. So, really, really important problem to address the issue of preventing, this kind of misuse. Okay, so at VinAI, we worked on the idea of a traceable generator. So, what does it mean by a traceable generator? So you know that today, an image generator takes a prompt, right? And it spits out an image, But there's no way to tell, right, whether the image is actually generated by the computer or not. And the idea of a traceable generator is that during the generation of the image, the generator can put in very tiny, not perceptible to the human eyes, watermark of the image, right? And so that we know, or the computer would know, what is the ID of the generator, right? So who actually generated these images, right? And of course, in order to do this, you have to make sure that once the watermarking is in there, it is robust with respect to all of these transformation, like compression, and transformation and transmission, and so on, okay? So if you can do this, then first of all, you have a benefit that you know the source of the generation process. Now, you also have the added benefits that you can put in things to protect IP, right? For example, you can put in information about the author, right? And I think this is a really, really important technology that not only that it's important today, but I think it's going to continue to be really important in the future when governments and other entities start to regulate this space more. Okay, so what about protecting my personal photos? Now, what do I mean by that? Right, today, there's technology, for example, a system called Dreambooth, that does what is called personalized text-to-image. So it starts with just standard photo, like my own photo, for example, and with some prompts, it will spit out a modification of original images, and with that, you can have fun. You can say, okay, generate a photo with Hung Bui in Sydney Opera House, or generate a photo of Hung Bui going skydiving. Okay, that's fun. Okay, this is not so fun, right? So you can ask the computer to generate an image of Hung Bui, right? Okay, well, I'm not so worried about the first one. I'm more worried about, the two images on the left here, right? Because if my wife sees, I'm going to be in big trouble. Okay. All right. So at VinAI, we worked on a technology called anti-Dreambooth. And what it means is that, again, you can't embed, again, yet patterns, right? But it's actually imperceivable to the human eyes. Put that in the image in such a way that if you do that, then text-to-image generation system no longer works properly, okay? And if you can do that, then of course you feel better when you put your personal photos out there, and that other people, it's less likely that they'll be able to use it for the wrong purpose. Okay. All right, so let's talk about efficiency and cost. Okay. Now, this is actually a really important topic, and something that has been highlighted by the previous talk. As AI model is getting larger and bigger, right, it certainly requires more powerful machines, and these machines are actually very costly. It also contributes significantly to potential problems, really important problems like climate change and global warming. Okay, so we also feel that, for example, in countries like Vietnam, for example, right, where everybody is very cost conscious and everybody is, is thinking very hard about issues like sustainable development. Right? How are we able to address these issues? How are we able to make sure that we have systems that retains the same capability and quality and so on, but we'll be able to serve them in a much more efficient way? Okay, so take image generation as an example. Now, this slide looks a little bit technical, but pretty much most of image generation systems these days work by taking, on the left-hand side, random noise, and then somehow, through multiple steps, processing, it generates very high-quality image. right? So that's the process. In this process, something called diffusion process actually takes many, many steps. Okay. So there are 3 ways, at least 3 ways, you can go about making sure that this process is more efficient. You can optimize the individual steps. You can also try to reduce the number of steps. Or you can also try to optimize the network backbone. Okay. So optimizing the individual steps. This is an example of something that can be done by thinking about the problem in a smarter and more intelligent way. Okay. So the technical people here are probably familiar with Fourier transform, right? So instead of doing the diffusion process in the image space, you can also ask the questions whether you can try to do this in the frequency domain, right? And we found out that, with just a simple application of a standard wavelet transform, instead of running diffusion on the original image, we do a wavelet transform. We run a diffusion process in the frequency domain, and then take the inverse wavelet transform. And by doing that, we actually able to speed up this process and also be able to generate higher quality images as well. And here's an example of experiments that we've done. Our system actually runs both faster, but actually also maintains the same standard, and sometimes the standard is even higher. Okay, so that's one example. It's a technique called wavelet diffusion. What about reducing the number of steps? Okay, this is also very important. The standard diffusion process could take maybe 50 steps or so, right? Can we just do it in 1 step? Or at least a lot fewer than 50, right? But if we can actually do this, then it will significantly speed up the generation process and make everything, consume less power, more efficient, and so on. Okay? And we found out that, yes, if you do it properly, right, you can actually have a system that takes very few number of steps, even 1 step, right, and generate this image with similar quality and significantly improve the efficiency of the system. Optimizing the network backbone. Okay, so this is also something very important. We've done a lot of work, not only in researching new models, but also in deploying these models in real use cases. So we've made our AI models work with embedded SoC, running real-time in the cars, and so on, right? And we come to the conclusion that it's really important to focus on how we actually optimize the backbone of all of these networks. Because if you do it right, then quite often, you'll be able to get quite a bit of performance out of the systems without affecting the quality at all. For example, if you do hardware-aware neural architecture search, or hardware-aware NAS, then quite often you come up with a different backbone, right, that can be optimized specifically for a particular hardware. And this is also really, really important. And let us show you the result of putting all of these ideas together. So let me introduce on stage Dr. Tuấn Anh Trần, and he's going to show you guys a demo of how our instant image generation is going to work.
Thank you, Anh Hưng, for introducing me. And today, I want to show you a demo to compare the speed of Stable Diffusion, a very common text-to-image generation model, and our one-step diffusion model. Okay, so as you can see on the screen, on the top, we have a text box, so we can input the text, and then we have a button to let the model generate images corresponding to the prompt, right? And Stable Diffusion will show the result on the left, and our model will show the result on the right. And to compare the speed of this model, we will let two models run in parallel. And each model will generate 6 images sequentially. Okay, so now let's try the default prompt, a river running through a forest. You can see that on the right, our result pop up instantly. In contrast, Stable Diffusion takes a while to generate each image. We also record the inference time required by each model to generate a single image on the bottom of the screen. And you can see that Stable Diffusion needs about 1.5 seconds, while our model only needs about 0.15 seconds. So it means that our model is about 10 times faster than Stable Diffusion, and it is almost real time. Okay, so now we can try a different prompt. Let's see how this is the same content, but at night. Yes. Again, you can see that our model is very fast. It is almost real time. Yes, and all images generated by our model are very dark, so they match quite well to the prompt, while some images of the Stable Diffusion are still quite bright, right? Okay, now let's try a completely different prompt, like a chihuahua next to the beach. Okay, so now. Yeah, again, we can see that our model is very fast, while Stable Diffusion is much slower, right? Okay. Okay, finally, I will close the demo by a very challenging prompt. I want to check whether this model know about one of our tourist attractions. It is Hội An. So the prompt will be a sketch of Hội An in autumn festival. Oh. Okay. Yeah. Yeah, you can see that both models know how Hội An look like, and we see a lot of old buildings and latent, right? Okay, so, but I think that our model is preferable due to its real-time speed. And this is the end of my demo. So, thank you, everyone. And now I will leave the stage for Anh Hưng to continue.
Thank you so much, Tuấn Anh. That's really great. Very interesting. Okay. So that's image generation. So next, let's talk about issues of how to make sure that these really important foundation models for AI is going to be available and accessible to everyone. Right? And as a team from Vietnam and also Southeast Asia, we think very hard about these issues. Historically, we've seen development of AI has been, first of all, targeted the first world, and it's actually understandable. Lots of use cases actually came from the first world. But also, that leaves big questions, right? What about developing nations? Will be able to really be inclusive and being part of this really important next phase in the AI development and revolution. And I think the best way to do it is to try to be part of the game, right? So at VinAI, we've, right from the beginning, worked very hard on foundation models like large language models. Very early on, we very actively worked on open sourcing these models as well, right? And so even before large language model is popular, we've released some of them, very interesting open source models for bird tweets, for X-phone bird, which is actually a multilingual model for phoneme representations in almost 100 languages and localities. And of course, there's a series of fur models, right? We've released FurBird, extremely popular model for the Vietnamese LNP community. Lots of usage. People really love it. I've got really fantastic feedbacks from FurBird. And of course, very recently, we released GPT, right? And GPT is, of course, a large language model for Vietnamese. And all of these models are actually very popular. It's been downloaded many, many times from Hugging Face. I've just checked, and last time I just checked, and there's already thousands and thousands of downloads from Hugging Face for GPT. Okay, so what is GPT, right? So you've heard the words, but I'm sure that a lot of people are very curious about what is it that we're doing, right? Pretty much, it's an open source LLM for Vietnamese. It's a 7.5 billion parameter model that we trained this model from scratch, Vietnamese data, and we did not fine-tune from another model, of course. So these models are very interesting starting point, and we made the decision to release this to the entire community with the hope that we'll be able to help other people very quickly bootstrap their development efforts and be able to make the best use out of this. So we've also done some benchmark for GPT versus other open source LLM when it comes to Vietnamese, right? And of course, for most of the tasks, we came significantly above other existing open source model for Vietnamese. When you compare to ChatGPT, then of course, we're behind. But we're working on the continued improvement of GPT to make sure that we have an open source version LLM for Vietnamese and also other languages in the region in the near future. So, I think people have been looking towards this particular moment. So I'm going to invite Dr. Dat Nguyen, one of our research scientists, and he's going to give you a taste of what GPT looks like.
Hi, everyone. So I'm going to show you a quick demonstration of GPT. So we just need to start with something like very basic prompt like Xin chào, hello. Xin chào, tôi thì giúp gì cho bạn is the response for GPT for the input prompt, and we then can asking him like bạn là ai? Who are you? So my name is and I'm actually a model developed by VinAI, and we can ask him something like what he can do. Bạn làm được gì? Ok, tôi là một chương trình máy tính được thiết kế tạo ra văn bản giống như con người và hỗ trợ nhiều tác vụ khác nhau. And actually, for GPT can be your friends. It's can keeping you accompanies. We can ask him something like, bạn có thích bóng đá không? Tôi thích xem và thảo luận về bóng đá. Okay, so we can ask him something like Messi và Ronaldo, which one is better? Messi and Ronaldo, which one is better? They are both very excellent football player. It's a very neutral answer, right? Of course, for GPT can empower your knowledge. It can be your education partner. So we can ask him something like, cách phòng tránh bệnh. How to prevent the dengue fever. So should it. Giữ gìn vệ sinh nơi ở, áp dụng một số biện pháp đốt muỗi, phun thuốc diệt muỗi mắc màn khi đi ngủ. We can consider it's quite good answer, right? And and of course it can be your assistant to help you with planning, or it can be something like applying for a job. For example, we can ask for GPT to write a letter for a job application, like viết đơn ứng tuyển kỹ sư AI. So some sort of like the letter you can send to the recruiter. We have something like dear tên người tuyển dụng, some sort of formal information, present the background of the people, of the writer, and then here we can have some sort of like reference to a well-known engineer in the field. So that's complete my quick demo for GPT. We set up a booth demo outside after this talk. So if you want to explore GPT further, please go there. Thank you. Welcome back, anh Hưng.
Thank you so much, Dad. Okay. So that just gives you a glimpse of what GPT is, and if you guys want to know a bit more, then we have the booth outside to give you a bit more time to see how the system works. Now, so that's interesting, right? It's a 7.5 billion parameter models. Seems to be doing something that's potentially very useful for Vietnamese. But we've heard loud and clear, right? Even from the previous presentation about issues that are associated with bigger and larger model, right? And again, I really want to go back to this point because this is so important for countries like Vietnam, where people are very cost conscious, right? And I personally think that it's really important to really address this issue about efficiency and sustainability when the world is moving towards bigger and larger models, right? And there were reports that surfaced a couple of days ago that each time someone generates an image, it consumes the same amount of energy as someone is charging the phone, right? So if this is true, then potentially this is significant and serious problem. Okay, so we've talked about how we deal with this for image generation. So what about large language model? Right? Optimizing large language model is also something that's really important, right? Equally important, so probably even more important than image generation. And after all, for GPT, as I said, 7.5 billion parameter model. So we looked at this and we see, okay, so what if you try to optimize these models? What are the challenges at hand? And once you start looking further, there's really two kinds of issues that you have to deal with. So you have to reduce the memory latency, you have to reduce the compute latency. And in this particular case, we found out that sometimes memory latency is actually a more important problem you need to look at. So at the end of the day, you need to look for methods in order to optimize for the model size, also the bit width, and also memory locations. Right? So these are all really interesting, but also intricate aspects of the algorithm and also the implementation. So to give you a perspective, right? So everybody knows that today, a large language model requires a big and powerful GPU. Right? So we're talking about the bandwidth, memory bandwidth. This is about 3 to 4 times higher than the bandwidth that's available in a consumer-grade GPU. Right? So imagine if you can somehow fit the large LLM into the smaller consumer-grade GPU, right? This is already offering significantly saving for developers, for people who are using the system. Right? Now, of course, there's also the holy grail, which is the phone. Right? Now, we've looked at this, and we realized that the memory bandwidth for the phone is about 1/100th of the memory bandwidth of the best GPU. Okay? So if we can actually do this, it's going to be something really interesting and even further cutting down the cost of serving these models. But really, can you do it? I mean, the big, gigantic large language models with millions of parameters in a phone. A tiny phone. So what do you think? Will we be able to fit a large language model, millions of parameters, on a smartphone looking like this? Okay, so let's find out. Okay, so what I have here, and okay, so what I have here is a nice-looking phone, but it's a phone that you can actually just go to the shop and get it today, right? No big deal, right? Standard smartphone. Okay, so on this phone, of course, I have ChatGPT. Yeah? Everybody has ChatGPT on their phone. Yeah, so okay, great. Hi. Hello, ChatGPT. How can I assist you today? Well, what about ask it to draw an image or a photo? I'm going to ask it to draw a photo of, let's just say, hang on, I'm going to change my keyboard. Of a river running through, okay, sorry about that, the forest. See how it works. Okay, it's taking some time, certainly not instantaneous. And this is not running on a phone, right? This is, probably, burning some GPUs in OpenAI server. Oh, interesting. Not bad, all right? Very good for ChatGPT. Thank you very much. Okay, so what I'm going to do now is try something a little bit more challenging for ChatGPT. And what I will do, I'll go in here. I'm going to put this phone on airplane mode. Okay? It's on airplane mode. All right? I think this is going to be very challenging for ChatGPT. Yeah? Are you still there? Network error. Okay, bye-bye, ChatGPT. All right? Okay, so when we try to run everything on device, of course, ChatGPT doesn't work. So what I'm going to show you is the ability to generate image with a system that runs entirely on this phone. Okay, so let's see. A river running through a forest. All right, let's see whether it works. No internet, again, no internet. This is not a trick. This wire here is only for projection, okay? Not a trick. Promise you. Okay, let's see. Rendering. Okay. It works on the phone. In the winter. Okay. Generate. Not too bad. Entirely on device. Okay, great. So, what about for GPT? Now, what do you think? Okay, let's see if this thing is going to work without any accessible internet. Okay, so since we're in Ho Chi Minh City today, I think a fitting topic would be maybe to ask for GPT to write something about the city. Maybe I'm going to ask it to write a poem about Saigon. Yeah? So I'm going to ask it to viết thơ, okay, viết bài thơ về what do you think? Nắng Sài Gòn. Okay, wait. Okay. Nắng Sài Gòn. Okay. See how it works. Again, no internet. Not bad. Ok, nắng Sài Gòn anh đi mà chợt nhớ, có phải vì em đã chót thương, Sài còn lạ lắm em ơi, đông nắng tây mưa hai phương trời. Not bad. Right? So it's actually a poem in Vietnamese, right? For the people who can understand Vietnamese. Okay, so I think that talks about sports and so on. I'm going to try to ask questions about soccer, certainly my favorite sport. La pulga, là biệt danh của cầu thủ nào? Yeah, fuga. That's messy. All right, that's messy. Okay. Okay. So since AI Day, of course, this is a AI event. People come here because of your interest in AI, and I'm sure that there's been a lot of talk about how AGI could actually be dangerous to our humanity and so on. So what do you think? Let's ask for GPT what it thinks about that topic. Okay? So trí tuệ nhân tạo có làm loài người tuyệt chủng không nhá? Loài người tuyệt chủng không? Oops. Okay, so here's the answer. Một số người cho rằng AI có thể gây ra những hậu quả nghiêm trọng cho loài người. Ví dụ AI có thể thông minh đến mức có khả năng tạo ra vũ khí và phương tiện tự động. Điều này có thể dẫn đến các cuộc chiến tranh nguy hiểm cho loài người. Tuy nhiên cũng có những người cho rằng AI sẽ có những tác động tích cực đến loài người. Alright? Tóm lại, mỗi người đều có quan điểm riêng về AI và những điều phù hợp từng cá nhân. Well, okay, I think it's a pretty safe answer from GPT. Okay? Now, last but not least, I'm going to ask for GPT to send a message to the audience. Okay? So let's do that. có nhắn nhủ gì cho khán giả AI đây không? Okay, how about that? Tôi hy vọng rằng AI Day 2023 sẽ mang đến cho khán giả những thông tin và kiến thức bổ ích về lĩnh vực AI. Đồng thời, tôi cũng mong rằng sự kiện này sẽ tạo ra một cầu nối bền vững giữa cộng đồng AI thế giới và Việt Nam. On behalf of GPT, it says that I hope that AI Day is going to bring to the audience really the best, the latest in terms of knowledge in AI. And at the same time, for me, as in for GPT, also hoped that this event is going to be the bridge between the local community here and also the global AI community. So thank you so much. That's the end of my presentation. Thank you.